All right. Last video we talked about the product to sum, and now we're going to do the sum to product. So we had to do product to sum first because we had to show you how we use the sum and difference identities to create those. But now that we're talking about sum to product, we're going to use the product to sum in order to create the sum to product. And if you guys or keeping notes, you have all four of those equations written. So all we're going to do is just manipulate those four equations to create the sum to product rules. And if you don't, well, here's what we're going to do. Over on this page, I have all of them. Hopefully this will allow me to move them. No, it won't. But anyway, these are the four that I'm going to use. Give me 1 sec so I can kind of copy them over to the next page, and we'll work on them kind of one by one. Okay, so now I have them there. We have the sine of x times the cosine of y, cosine of x, cosine of y, sine of x, sine of y, cosine x. So all four different combinations, nice and color-coded. So the first thing we're going to do is we are going to use the sine of x cosine y equation to create sine of x plus sine of y. So I need to choose the x and y options, these x and these y's that'll go in here. I need to choose them very carefully. So what I'm going to do is I'm going to do sine of an x plus y divided by 2 times a cosine of x plus, oh, not plus. I want to do minus, I believe. Yes. Yes, that is what I want. This one should be a minus over 2. Now, this is where you guys have to kind of accept that in the past there were some really thoughtful people that really considered, well, what would I have to use for these angles so that way I could get something really nice? So they had kind of that vision that they just kind of implemented. So that's where I'm getting these angles kind of out of the thin air, because I'm just following that person's vision and just explaining to you how they did it. So if I have this representing the left side of the equation, right? So I'm going to go ahead and replace it into the other side. So that means that this should equal 1/2 sine of, now the x was whatever was inside the sine function. So I'm going to use that x plus y divided by 2 plus whatever was in the y, whatever's in the cosine is going to act as that y value. So x plus y, whatever's inside the cosine, divide by 2, close it, plus sine of whatever was in the x minus whatever was in that y spot, whatever's inside the cosine. Okay, now bear with me because this is kind of a, last video I had to cut short because I was going to do it all, but I got confused. So if we understand kind of the color coding that I'm doing, where this represents that Y spot in the identity, and this represents the X spot in the identities, all I have to do is try to simplify what I have. So right here, then this would have to equal 1/2 sine of, well, it'd be a 2x over 2 plus sine of, and hopefully you guys are careful because I'm subtracting. So when I subtract, this turns into minus, this turns into plus. And when I combine those two numerators, I end up with 2y over 2. Close it, bracket, cool. So really I have this right here, sine of x plus y divided by 2 times a cosine of x minus y divided by 2 equals the 1/2 times whatever a sine of x plus a sine of y equals. So by doing just one nice easy multiplication, I can end up saying that 2 sine of x plus y divided by 2 times a cosine of x minus y divided by 2 should equal sine. I'm so sorry this is sloppy, guys. I miss writing on the whiteboard. So that's one of my sum to product identities. If I ever see a sine of x plus a sine of y, I can replace it with 2 sine of x plus y divided by 2 times cosine of x minus y divided by 2. That's an identity that we can use. So if I can do that with the yellow equation, I'm going to go ahead and look at the red equation on the right side there, the one that says sine of y cosine of x equals 1/2 sine of x plus y minus sine of x minus y. And we'll talk about that one real quick. Just let me set up. All right. So I'm going to go ahead and erase all this work and show you how I'm going to manipulate the red equation based off of the yellow equation. Because hopefully you guys remember from the previous video that these kind of come from the same thing, like the same sum and difference identity. The only difference was, no pun intended, what I plugged in for the x and what I plugged in for the y. So if you notice between the yellow and the red as I'm erasing, the x and the y switched. So I'm going to choose to view the red equation as cosine of x times sine of y. It's still multiplying the same two things, but I'm keeping the x and the y order consistent because that's going to make it easier for me, right? And just how we had this for the x and the y, I'm now going to have, let's do purple. Actually, yeah, I'm just going to switch out, get rid of the sine, replace it with the cosine. Yeah. Cosine of x, sine of y. is going to go in for x and y. Right, but it's going to be a very similar setup because it's a very similar problem. If I do this, I would have this equal 1/2 sine of the x would be that x plus y divided by 2 plus, well, this over here is the y value, so to speak, that second angle, x minus y divided by 2, close it, minus sine of the first angle minus the second angle. All right, and just like we were doing before, my goal is to simplify whatever's inside the sine functions right now. So I can say this is just going to end up being 1/2 bracket sine of 2x over 2 minus sine of, again, if I distribute this negative here, that's going to be negative. That's going to turn into plus. X minus x goes away. Y plus y gets me 2y, or the denominator of 2. So then we are left with cosine of x plus y divided by 2 multiplying a sine of x minus y divided by 2 should equal 1/2 sine x minus sine y. So then to free up the sine of x minus sine of y, right, because I want to show that as a sum, I would just have to double the other side. So it'd be 2 cosine of x plus y times sine of x minus y divided by 2. And that's the sine version where I would subtract sine of x from sine of y. All right, so if I ever see that, I can just rewrite it in this form. So that's what I do with the sines. I'm going to show you one with the cosine, and I'll have you work with the other cosine equation as part of your assignment. All right, so now we're going to talk about cosine of x plus y divided by 2 multiplying a cosine of x minus y divided by 2. So because it's cosine times a cosine, I'm going to use the blue equation as that's why I chose blue right now. So it's going to equal 1/2 bracket cosine of the first angle, which let's call this the first. So x plus y divided by 2 plus the second angle, which is this one, x minus y divided by 2 plus cosine of the first angle minus the second angle. All right, so all I did was take the givens, plug them into the equation. Now I'm going to simplify because at the end, what I want to know is what cosine of x plus cosine of y should equal. That's my sole purpose right now. So if I manipulate what I have so far, I have 1/2 cosine of, well, this pattern is just going to keep repeating itself. This is going to turn out to be a 2x divided by 2 plus cosine of, and this pattern is going to repeat itself. This is going to be negative. That's going to turn positive. So that's going to give me 2y divided by 2. So I could end up saying that cosine of x plus y divided by 2 multiplying a cosine of x minus y divided by 2 should equal a 1/2 bracket cosine of x plus cosine of y. So then to end up solving, I have to get rid of the 1/2 outside the bracket, so I'm just going to go ahead and double both sides. So 2 cosine of x plus y over 2 times cosine of x minus y divided by 2 should equal cosine of x plus cosine of y. And that's that. So for your assignment tomorrow, part one of the questions is going to be go ahead and figure out what the cosine of x minus y should equal based off the product to sum identities. So this video will hopefully help you with that. Next video, I'm going to show you how to actually apply some of these to verify identities.